A professional robber plans to rob some houses along a street. Now, these houses are arranged in a circle, which means that the first and last houses are neighbors. The robber cannot rob adjacent houses because they have security alarms installed. Following the constraints mentioned above and given an integer array of money representing the amount of money in each house, return the maximum amount the robber can steal without alerting the police. And these diagrams can help us see what we're talking about. So we have these houses, the last is connected to the first. And so if the best he can do is pick 5, because if he picks 5, he cannot pick 1 or 3, because that would alert the police. If he picks 1, he could only get 3, which is 4, which is less than 5. And that's why 5 is the best house for him to pick. Now in this case, we have two things that amount to 4, 1 and 3, and 2 and 2. So since both of them result in 4, and they have lower amounts if selected alone, right? Because if each one of these don't sum up to 4 individually, like as individuals, the maximum amount he can rob is 4, and there are 2 ways for him to get that. Now in this case, the best amount is this, 10 and 1, and because it's better than 2 and 2. Okay. Now here we have 2 and 2 here, because it's better than 3 and 0. Okay. Now, the solution to this, right, requires that when you have the money initially, the houses, like with the money, this array represents the money in each house. I remember the last thing is going to get to the first thing. So the first thing we want to do is split it into 2 parts and perform the steps on both separately. So we have set 1 and set 2. And set 1 has the first thing but doesn't have the last house, right? And step 2 has the last house, right? As you can see, 3, but doesn't have the first house, 7. Okay, and now what does that look like in code? I think it's worth looking at. So these are preliminaries that we would need, right? So if there's nothing, right, the length is an empty array, the money array is empty, there are no houses, so just return 0. If it's just one house in the neighborhood, then just return that one house. There's nothing adjacent that can trigger or call the police. And then we're gonna look for the maximum value we can get from those 2 sets. So at the end of the day, we're gonna look for the maximum we can get from these 2 sets of houses, and that's gonna be our answer. Okay. So next, what do we do with the set 1? So this is set 1. First thing we're going to do is create this lookup array by initializing a lookup array of length n plus 1 with zeros, where n is the length of the money array. So the length of this plus 1 we make is 0. So this is length of 4, this becomes length of 5, and we seed everything with zeros, and that's what this looks like. So money.length plus 1, you can see that we're filling it with zeros. And then what do we do afterwards? The first index of the lookup array is 0, since it's the base case. Now, what does that base case mean? It means, okay, if we had no houses we're considering, what's the most we can make? And then the answer to that is 0. So we see that was 0. And now for the first house, we can only rob this first array over here. Means, okay, if we have only one house out of this array to rob this first house in consideration, what's the best we can get out of it? And the answer to that is that house. We add that house to the array. And that's what that looks like here. So we're seeding the first thing with 0, representing 0 houses. So seeding the first thing with the first item in the money array, representing, oh, if we only had that house in consideration, that's the best we can do. And we're using those subproblems to get us the solution when all the houses are in consideration, similar to the classic knapsack problem. And so what is next? So the next case, we have 2 houses in consideration. Now, for these 2 houses, the best thing we can get, right, it's either to pick this first house and skip this second one, right? And it's going to be represented by picking this house and evaluating, oh, we didn't pick this first house. Because again, if you pick both of them, you'll call the cops. So we're picking the case where we evaluate the case where there's no house, and when there are 2 houses. And we're skipping the case where there's only 1 house. And so what does that look like in code? This calculation, I wish they added more color, because it's a bit hard to grok, but the code might make it stand out a bit more. So let's look at that instead. So we're looping from considering 2 houses and above up until the total length of the houses in the neighborhood. And what we're doing is checking, okay, well, which is better? Assuming we are considering only the last house, right? So in this case, assuming we had only 1 house, is that better than if we took the money in this house, represented by this, right, I minus 1, because again, we added 1 to the length of the arrays and the lookup array. And the best, assuming we skip this house and got the one before, which was represented by this value over here. So that's already, in this case, assumes we take the money in the current house and what was best in the house prior, 1 step over the one before it, that came before it, or we just pick leave this house alone, leave this money alone, because it's not up to what we had in that last computation. And that's what this represents, all this math that they're doing here. So you see they do the addition here. So in this case, it sums up to 4, right? So in this case, we're doing a max of 4. This winds up being 4 and 7, which we had before. And the bigger one is 7, so that we set that to 7 over here. And we do the same thing here. So okay, do we consider this house, or do we skip it entirely and pick the best thing when we consider this house instead, which is the same thing with 7. And so this top thing here, in this case, winds up being 1 plus 7, which is better than if we just consider that last house and didn't take the money here. So in this case, we're taking the money here, and that's going to give us 8. And then we do it again till we get to the end, right? Because again, we're looping to the end. And that brings us down to 16. So we say, okay, what if we take this thing, right? Is it better if we take this thing? And so if we take this, we're going to add it to what was best here. Not this necessarily, but what was best here, which turns out to be 7. So 9 plus 7. And by the time we consider this house, it was better to pick this and skip this. So in this case, we're picking this, right? And this. Now it works because this is a subset, right? It's not the whole array. Otherwise, you know, that would trigger the cops. But we've already done that separation earlier. So 9 plus 7 gives us 16, and 16 is better than 8, right? Which is over here. The best if we considered only this house. Okay? And it follows with a knapsack problem. Your intuition for this solidifies the more of these problems you see. So don't just rely on one dynamic programming problem. Solving one of these just to think you've mastered it. And then we're done. We know the best thing considering this set of the neighborhood. And that is 16. Then we do it again, but for the second neighborhood. As you can see here, we call this function twice. So in this case, we didn't consider the last element. In this case, we didn't consider the first element. And we do the exact same thing. Exact same thing. And we get 13, and then we check the max between the two of them. It turns out to be 16, and that turns out to be our answer. Right? We do the max between the both of them, and that winds up being the answer we're looking for. So next, let's check the time complexity of this problem. It's O(n) because we only loop once, right, across everything. Well, we technically 2n, right, because we're looping twice here. We're doing it twice for 2 sets of the same array, but 2n evaluates down to n. And the space complexity is O(n), which is space used by the lookup array. That's it. And then there's a way to solve this with a single array, but we're not going to go into that because I feel it's less intuitive. LeetCode's explanation of that solution was a bit annoying, so I was like, yeah, I'm just going to skip it. But this should work and be satisfactory to any interviewer. So yeah, that's all.